So one of the problem from your first module is for the series diode configuration of the figure, determine VD, VR and ID. This is example 2.4 from your Boylsted textbook. So this is your given figure. You have a supply, right? E, which is given as 8 volt. Then you have a diode in forward bias condition, positive, negative. The voltage across your diode is taken as VD and you have your VR, right? VR, the voltage across your output voltage, VR across your resistor, which is a resistor value is given as 2.2 kilo ohm. What are the parameters you have to find? You have to find what are the values you have to find. You have to find out VD, VR and ID. Okay. So from the figure solution, from the figure the diode is in the on state, right? Here also it is positive, here also it is positive. So your diode is forward bias, it acts as a closed switch. So this will be your current flow, and the clue given in your question is it is your silicon diode, right? So from the figure the diode is in the on state. Okay, since the diode is silicon, what will be your value for VD? The cut-in voltage, diode voltage will be equal to 0.7 volt. Okay, so first parameter we have found out. VD is equal to 0.7 volt. So if you apply second step, what you have to do is you have to apply KVL across the loop. So what you will be getting here, it is plus to minus. So plus E, second polarity, plus to minus, minus VD, plus to minus, minus VR. So E minus VD minus VR is equal to 0. So from this you know already, you know the value for VD. Now you know E. Now what you have to calculate? VR you have to calculate. So if you reconfigure, VR will be equal to E minus VD. What is your E given in your problem? 8 volt minus VD is already you have found 0.7 volt. So you are getting VR is equal to 7.3 volt. You have got the second value also, VR. Now you have to find out what is the value for your ID. The same current flows here, right? So ID, I can equate that ID is equal to IR. The same current flows through the load also. So ID is equal to IR. What will be your IR? In terms of Ohm's law, V is equal to IR, right? So IR will be equal to V by R, VR divided by R. You know the value for R here. And you know what is VR. Can you calculate what is IR? IR, which is equal to ID. ID is equal to 7.3 volt divided by R is equal to 2.2 K. Okay, so after solving you will be getting ID is equal to 3.32 milliampere. Okay, so the same problem can be extended by means of the second example problem. See here, example 2.5, repeat the same question with the diode in the reverse condition. So when you reverse bias the diode, what will happen? It will act as an open switch, right? So when the diode is reverse bias, it acts as an open switch. That is, the circuit, previous circuit will be modified into this corresponding circuit. It will act as an open switch. Okay, so what will be a current flow? Current flow will be, it is open switch means current is equal to 0. So ID is equal to 0, IR also is equal to 0. So you know that what is your VR? VR is equal to, V is equal to IR, right? So VR is equal to IR into R. You know that IR is equal to 0. So what is your VR? VR also is equal to 0 volt. So when you apply the Kirchhoff voltage law, same law, E minus VD minus VR is equal to 0. Already you have got VR is equal to 0. You have to find out what is your VD. You know the value for E. So when you reconfigure it, VD is equal to E minus VR, right? So what is your E? 8 minus VR is equal to 0 volt. So your VD will be equal to, so here it will be equal to 8 volt. It will not pass to the second stage. So